morning, everyone.
Good night, sir.
Have, have a great day from all over the world. I believe you are doing great. And today I'm your host. My name is Shahriar Chaudhuri. And can you see my slide?
Not yet, sir.
Sorry. Share this here. Now, can see my slide?
Yes, sir. It's on now.
Yes, sir.
Okay. Thank you so much. Having with me. Have a great day. And my name is Shahriar Chaudhuri. I'm lecturer at Friends of Songkhla University. My research expert actually solar energy, solar recycling, e-waste, and solar photovoltaic recycling. So today I'm going to discuss about solar photovoltaic energy. And our discussion after my lecture, we will discuss, we will collaborate and we discuss each other, how could make a new policy. And before start my session, would you mind, can you open your camera so it can maybe interact each other? Today our discussion about climate change, why climate change, and also we'll know about the solar photovoltaic history, technology, market share, and manufacturers like different countries, how is the market, and also we'll know about the solar application where we can apply solar energy, and how can it help us to develop for how can help us for sustainable development. That all from we can, I will discuss about that. So before go to the solar energy, I would like to show about some scenario about the world energy demand, because we know that for our current 21st century, we are developing technology, and also we are we try to um, uh, we try to change our living style, and we try, new device, uh, lots of things. So how could it possible? Because of for all things actually from energy, we need energy. So how could it? There are many sources of energy like coal, oil, and natural gas, nuclear, and other also renewable energy sources. So we can see also the maximum energy sources from coal and oil-based power station. And third position is natural gas. Nuclear gas also currently some of country they are focusing nuclear power station, but problem is that nuclear waste is very dangerous, and nuclear radiation also not good for human health and environment. And coal and oil, we know that CO2 emission from coal and um, oil-based power station, and at the same time also the resources, we need to think about our resources. How can we cover it, because in future generation they may not have that kind of resources to utilize generate the electricity. So that's why we have to think about that. So when we try to develop our energy and our technology. So it's sort of things like um, destroy our environment. It's not working. Okay, I'm sorry. Destroy our environment. We can see that this is the USA scenario. So we can see the 82% carbon dioxide they are reducing, and we also can see that maximum from 28% from transportation, 28 from electricity, and also industry. So we know that they already developed their technology, and they try to go to like space. They try to do many things, but at the same time we have the problem is that CO2 emission. So in USA they, that is the big problem now. And we can see also that China, there are 3 or 4 countries, they're trying to develop a technology, and also at the same time, they destroy our environment. We can see that China, United States, and Russia, they also, most of the part, they polluted our environment. And our developing countries, we are suffering the problem. So how could it possible? If we do not, and we can see, what happened?
To change the screen to screen. Share
How,
screen.
how can, I don't know.
Okay.
Sorry for that. And we can see also that CO2 emission yearly from 1752 is gradually increased, and after 1950 it was dramatically increased, and now almost 35 billion ton per year. Can you imagine that? Why climate change? That is the big reason. So if we do not protest it, and if we will not protest it, what happen in future?
Sir, if
If
I may, these big countries or these developed countries, if I may, sir, please, these developed countries need to be held accountable for what is actually happening because, like you said, they're emitting most of the CO2 into the environment, which is speeding up the climate change or global warming. And developing countries, like our small developing countries, we're actually feeling the blunt of it, and nobody is actually saying nothing about it. I think the world needs to actually hold these people accountable. One of the things majority in the course we talk about is in the program we talk about incentives for using alternative energy. All right, sorry, sir. Sorry, I
uh, we
just
may
wanted to share that. Sorry. Go
call
ahead.
you end the session, okay? This is the starting. It's okay. And then we can see that what happens, and also increase the temperature, and increase the sea level, and deforestation, and also the uh, people lost also the harvest. And we also we cannot do any like due to the increase the temperature, people many disease. So that is the scenario actually. So if we not think about now, so we have to face that kind of scenario in future most. So is there any solution? Yes, we know that problem, we have problem, and we have also the solution. We there how can we protest it? There is the renewable energy. We can, instead of coal, oil, and natural gas, we can use renewable energy such as hydro, and biomass, solar. So solar energy is the most cheapest and also the most promoting energy currently. So we can promote it, and that is the big solution for us for a future sustainable development. So what is the solar energy? What is the solar cell, photovoltaic cell? So solar cell is called a photovoltaic cell. Is any device directly converted energy of light into the electrical energy through to the photovoltaic effect. So here we can see the solar device. There is a like a terminal a terminal is one kind of circuit. So how does it work? We can see also that it's receive sunlight and it make it photon and electron, and we receive the electricity from sunlight. So there is a there are many kind of solar cell in the world. Later on I will discuss it. So how does solar panel work? Solar panel actually PN junction is the one kind of P-type and N-type silicon. But normally, currently, silicon-based solar cell available in the world, and it's like a P-type and N-type silicon, and it create a PN junction, and we receive the electricity. History of solar cell. The solar research is not now, is from long time ago, almost 1839. In Mont Becquerel, he first time discovered the solar photovoltaic energy, and he discussed also the solar. What is the solar? How can we utilize it? And generation by generation, Albert Einstein also he explained the photovoltaic effect in 1905, and also 1941 Grendel developed the photovoltaic cell based on the Coffrus Excite solar cell. He reported that, and finally 1954 successfully United States they announced the solar silicon based solar cell with a 6% efficiency. That was the big achievement in 1954. So this is the solar radiation. There are many kind of radiation like X-ray or ultraviolet, also the infrared. So this is the we can visible range only this one, and the range from 200 to 100. Yeah, 1200 nanometer. So there are many kind of things, and solar radiation is term which is the use describe visible and is visible, and also the radiation is emitted from the sun, and the solar radiation is which is described from infrared is not visible. Is uh, the limitation of only atmosphere, we cannot see it, so that's why we cannot use it. And on the other hand, the solar radiation, which is incident outside of atmosphere, called the terrestrial solar radiation. And the terrestrial solar radiation is different because of the Earth rotate around the sun and elliptical orbits, and hence it is the sometime nearest to the sun. While on the other time, it is at a distant place of the sun. Here we can see the same things. The visual point is from 250 to 1250. So that reasons we normally silicon-based solar cell, they can absorb from 300 to 500, and currently the perovskite solar cell, they can absorb almost 500 700 500 to 700. There are many kind of absorber layer materials. Those can absorb the sunlight, and like germanium acetate, and germanium, silicon, and CDD, cadmium telluride, CDS, and also the silicon based. But germanium acetate is used for the, is very expensive and very high efficiency, but it was used for, it is used for the satellite because due to the expensive materials we use for satellite. But commercially only available CDTE, cadmium telluride thin film, and also the silicon based solar cell. Solar energy, there are three kind of generation, like monocrystal, polycrystal, silicon-based solar cell, crystalline silicon solar cell. It's like monocrystal and polycrystal. Second generation solar cell is amorphous silicon, multi-junction silicon, multi-junction CDS, and cadmium telluride, and also the CIGS, the second generation solar cell. Third generation solar cell concentrator, photovoltaic, disensodized, perovskite, or hybrid solar cell. But silicon-based solar cell now currently available in the market. Maximum is silicon-based solar cell, and also the thin film, like second generation. It also, the second position is like amorphous silicon. Some in Japan, some Japanese company, they are fabricate the amorphous silicon, or and CDTE, only one company they produce. Later on, I will discuss about that. And the third generation solar cell is a perovskite solar cell, and also other disensodized solar cell efficiency is not too much. So that's why now current world focus on the perovskite solar cell, because it's within short time it's achieve a highest efficiency, almost 20, 25, more than 25, because perovskite solar cell discovered not too much time. And we can see the module of solar cell, like first generation solar cell is look like this, and second generation solar cell. What is the difference between first generation, second generation? First generation solar cell thickness is 1 micron, one micron, 1 to 2 micron. But second generation solar cell is 500 to 700 nanometers. So that's why it's very thin, and that is the difference between. And also the first generation, second generation solar cell efficiency is not expensive also. And third generation solar cell thickness is almost 300 nanometer to 500 nanometer. It's not too much. And this is the disensodized solar cell. It's like transparent, we can call also transparent solar cell. We can use it for on the glass like building, but efficiency is not too much. That's why it's still now under consideration, like under research, and in future it would be available. So first generation solar cell, there is only one layer, and one layer, when they deposit the silicon, they use the gas, and that gas can make a silicon a p-type and n-type junction. They created the p-type and n-type junction. And also they use soda-lime glass, and for back metal contact we use on back metal contact use the silver, and also the glass we use also the FTO, like FTO coated glass or ITO coated glass, and also use the anti-reflective coating for safety of the stability. And we know that first generation solar cell lifetime almost 20 to 25 years. It depends on the materials also sometimes, or manufacturer, because if we buy some cheaper companies, so they have some cheap materials, purity of materials, so that's why you receive lower efficiency, like 15%. Even they say that 20% efficiency, but it's not actually 20, less than 20. And yeah, currently this one is available. So now we can see actually how first generation solar cell fabricate.
Welcome
Hello?
to the
Now
Solar World
sound is
Module
okay?
Production Plant in Freiburg. Every day
Okay, sir.
around the clock, a fully automated production process produces solar modules using 4 main production steps. Layup production, laminate production, module production, and finishing. A main component of our solar modules is glass. Each day, 4 trucks deliver 100 tons of the 1.60 times 1 meter large and 4 millimeter thick plates. This safety glass is similar to that used in car windshields and is treated with an anti-reflective coating. The glass plates are fed into the production process automatically. A large washing machine cleans and dries the glass before it is processed. The purity of the glass is an important factor for the efficiency of our solar modules. In the second step, the glass is covered with a so-called EVA film. Later, this film tightly seals the cells, permanently attaching them to the glass. Latest generation computer-assisted conveyor lines intelligently control the production flow. The systems independently recognize which of the 8 production lines must be supplied with material. With this design, even maintenance work can be performed at any time without halting production. This process has been developed by the specialists at SolarWorld and is unique worldwide. After they have been checked and sorted according to capacity, our solar cells arrive in the module factory securely packaged in special carriers. Here, they are again checked for any possible damage. A robot connects 10 identical cells in a chain, known as a string. The solar cells are soldered in series, on both the front and back, creating the strings, which can generate about 5 volts of electrical potential. Our employees give close scrutiny to the string before the fully automatic production process continues. 6 of these strings, laid next to each other according to the polarity, create a matrix of 60 solar cells. The cell strings are then soldered together in series, so that the module delivers a total power of 245 watts DC. Now properly mounted on filament glass, the future module is sent on to further production steps. It's given a second transparent EVA film and a very robust rear film that resists the system voltage of photovoltaic systems of up to 1000 volts without any problems. The complete package, experts call it a layup, is subjected to additional testing procedures. The electroluminescence measurement, for example, reveals possible hidden cell breakage. The trained eye of our module specialists also helps guarantee consistently high product quality. Properly sorted into groups of 4, the modules are now laminated. A look inside the laminator reveals exactly how this works. Glass, films, and cells are warmed in a first chamber to approximately 150 degrees Celsius. In the second chamber, the EVA films are melted, while the air between the films is removed by a vacuum. Solar glass, solar cells, and films form the so-called laminate. The module cools in a third chamber, and after approximately 24 minutes, it leaves the laminator as a sealed, weather and shock-resistant unit. In the following production step, our solar modules receive their patented flat connection sockets. This is a seamless process. With welded joints rather than soldered joints, it ensures maximum adhesion even under the highest loads. In the framing station, complete automation also ensures the best quality. The frame elements are given the correctly fitting corners and are filled with a 2-component silicone. Pressers then squeeze the frame parts onto the laminate and slot them together with the corner pieces, forming a stable whole. The module must once again prove itself in the flasher. It passes fully automatically through a second electroluminescence test, as well as the insulation and high voltage tests. Power rating is determined, and the module is classified under worldwide uniform standard test conditions. In the final production stage, the connection sockets of our solar modules are filled with silicone, which provides protection for the contacts against corrosion and mechanical load. When everything is correct, the connection socket is sealed and the cables are attached. The rear label gives individual information on the type, power rating, and production site. A last comparison of all test results and a final visual check by our experienced module specialists guarantees the proven SolarWorld quality. A robot sorts the modules according to their product and power class before they are securely packaged. The finished module pallets are transported by our logistics division to an intermediate storage site or are loaded directly onto trucks. Up to 6,000 solar modules leave our plant in this way every day. This amount would cover 1.5 soccer fields and can supply 350 houses with electricity. The production of solar modules can hardly be faster and more energy and cost efficient. And we are thinking further still. Today, our module plant already produces a large part of its own power. This is what we stand for at SolarWorld. We turn sunlight into power.
Am I audible? So this is the scenario of first generation solar cell, silicon based solar cell, and the many company they are fabricate, and this is the second generation solar cell. First generation solar cell, they doesn't have the direct absorber layer, they have only the silicon, and they use the gas, and that can make a absorber layer, at the same time also the p-type n-type junction, and produce the electricity. The second generation solar cell have the absorber layer, and at the same time absorber layer also work as a p-type layer. So they use, as a absorber layer, they use like a CDTE, cadmium telluride, and they absorb the light, and also convert p-type and divided proton and electron, p-type and n-type. And also they use another layer for as a CDS, cadmium sulfide, as a n-type. And also back contact, they use the pseudolim glass, and also sometimes they use FTO coated glass for transparent, and also they use the front contact, and pseudolim gas and glass, and this light put, and then it divided p-type and n-type, and produce the electricity. So this is the manufacture process from Fast Solar, and we will see now how does Fast Solar they fabricate the solar panel. Is it audible now? Anyone can help me?
Yes, sir. It's audible.
Yes,
It's
sir.
okay.
Yes.
Thank you. And third, perovskite, third generation solar cell, most promoting, and this is the, and also the high efficient, the perovskite solar cell, still now under research, perovskite solar cell. And perovskite solar cell, there are three kind of device. Masaika and his research group from Japan, they first introduced perovskite solar cell. It discovered first time 2009. And within 11 years, the perovskite solar cell achieved more than 25% efficiency. Currently, it's under research due to the stability issue, because some of researchers, they say, they reported that the stability of perovskite like 3 months, or some of them they want to say that 500 hours. The problem is that if we compare with other solar cell and perovskite is cheaper, and also it's also environment friendly. And but due to the stability issue, it's still under research. And here we can see the different type of perovskite solar cell, planar, inverted, and mesoporous. This is the perovskite absorber layer. We use as the absorber layer perovskite. Perovskite layer is actually the mineral, but the structure of perovskite is look like perovskite materials. It's so that's why we call perovskite. And the perovskite solar cell absorber layer fabricate, like we use AVX3 structure. We use methyl and methyl ammonium. Totally, we use the methyl ammonium iodide, and this is the perovskite. And HTM, whole transport layer, and ETL, electron transport layer. And electrode, we some of research, we say that gold is very effective, but due to the cost, we also use silver. And we use glass and FTO coated glass. Sometimes some researchers, they use ITO coated glass, indium doped tin oxide, or some use the fluorine doped tin oxide glass. And the difference between that, the reverse of, you see, we can see that the planar structure, HTM first electrode, then HTM, and then perovskite layer, absorber layer, and ETL, then the FTO, and then the glass, pseudoaluminum glass after that. But inverted structure, totally reverse. First we put the electrode, and then after that we put the ETL layer and perovskite solar cell. After that, HTM and the FTO glass. And mesoporous structure, we just use a composite layer, perovskite. After ETL, we use mesoporous for increase the stability, but still it is under research. So this is the actually perovskite. How does they fabricate the perovskite solar cell? It's different from first generation and second generation solar cell. So we can see also the fabrication process. This is the lab scale process. And this one also, the how does transparent solar cell. This is still actually due to the efficiency, so it's not available. But how does it work? It look like a glass, and we can use it like future solar car. They can use it, or we can use our window glass, and then we can also gain electricity from that. So solar photovoltaic cell, it's not like only one things, and they have a solar panel also needs support like solar inverter, and also because we receive actually DC voltage, so we need to convert it AC voltage, and then switchboard we can use it direct household, and at the same time if you want to send to grid, or we want to save it, so we use a multi-mode inverter like again AC to DC, and save the battery, and we can transfer to generator also. So this is the other component. This is the part of also the solar energy, because we need also the good technology for that. For inverter also we need good technology, otherwise it's a loss, system loss will be increased. So this is the market share, the solar energy. We can see that in 2014, the market share was 92% of silicon-based solar cell, and also the thin film based like a CDTE I mentioned earlier, it was 7% only. And other solar cell like Dyson Sodites solar cell, perovskite is still now not in commercially available. So it only 1%. And researchers also predict that it reduce 73.30% in by end of 2020. It's already gone, and thin film will achieve 10.40, already achieved it, and others solar cell third generation 16.30%. But according to the report of International Renewable Energy Authority, they reported that they predict that by end of 2030 it might be 44.80% silicon based solar cell. Second generation, it would be 11.10%. And third generation solar cell like Dyson Sodites or perovskite solar cell, it would be 44.10%. So it makes it 50-50 share, first generation and third generation. According to the NREL, National Renewable Energy Authority from USA, the solar efficiency is still now silicon-based solar cell 26%, and also the gallium arsenide, it's almost 47.1%, but due to the expensive material is not available for local market. And the Dyson solar cell is not too much, almost 10%. And second generation solar cell CDTE, it almost 19% on 22%. Some lab scale researchers show that say they reported that it's 22%, but commercially actually due to the material issue it's 15 to 17%. And perovskite solar cell, we know that is still under research, but it almost 25%, more than 25%. So this is the application. So before go to the solar photovoltaic application, may I ask anyone have any question about regarding the material synthesis? Anyone have any question or any suggestion? Anyone have question, sir?
No, sir.
Thank you, sir. And this is the application we can apply our telecommunication, agriculture, and rural electrification. You know, the solar panel is very cheaper if we compare that to other renewable energy sources. We need huge budget, but solar anyone can set up their rooftop or a remote area or remote island. We can use it, and for telecommunication, radio station, we can there are huge application of solar photovoltaic. So this is the future application of solar photovoltaic. Before I go to that, can we go for break, or after the video we can go break?
After video, sir.
Okay.
After video.
Okay. Thank you.
Solarpunk is a
The
sci-fi
future generation,
futuristic
how
view
we-
that sees our world and technology being powered by solar. It is a future that is broken away from the fossil-fueled ways of the past, and a future that connects humans, technology, and nature together. This video takes a look at the futuristic ways our cities, homes, and lives will be taken over by solar power. Everything from cities filled with solar trees to building drones with solar panels. And what happens when you add robotics and AI to solar panels? Will they be able to start thinking for themselves? And how will that change the solar movement? What other ways are people building solar farms as they move beyond land and build floating solar farms? And start looking to the skies. We will be ending this video with solar balloon towers and how solar panels will be fused with Tesla's Cybertruck. And what other ways will solar panels and solar power be used to build a more technologically advanced world? Since the amount of energy that the sun strikes the Earth in 1 hour is enough to power all of humankind's needs for a whole year. Will there be a day when our city and town streets are lined with solar trees mixed with natural ones? Cities from Singapore to Marrakesh already have these futuristic solar trees. Merging solar panels with a tree structure allows for more solar panels to be used without taking up more floor space on the ground, as the structures reach up and branch out. They also provide shade for hot city streets or even parking lots. And depending on the design of the solar trees, they can also give an area a more sci-fi-like and futuristic landscape, even lighting up at night. There are a number of companies that work on building solar trees, such as Spotlight Solar, Envision Solar, Smart Palm, Artemide Outdoor, and Smart Flower. You can see the solar trees being used in different places around the world. In Florida, solar trees have been popping up in zoos, near museums, airports, and parks. India has created the world's largest solar tree with 35 panels at the CISR CMERI residential colony in Durgapur. And then there is Singapore, who has created a skyline that looks like a Photoshop concept image. But these are real solar trees. There are 18 super trees that collect rainwater and work as cooling ducts, and 11 of them have solar panels, which powers water pumps and powers the super trees when they light up at night. The super trees also draw in air, sending it upwards, creating a breeze at ground level. Visitors are able to walk up among the trees along the skywalks that connect them. All of this is part of Singapore's goal of creating a city inside of a garden. What happens when you start mixing robotics with solar panels and make them smart machines that start thinking for themselves? The reason for adding robotic elements to a solar panel is as the sun moves during the day, and even the year, you want the solar panels to move too, just the way sunflowers do as they turn to follow the sun's rays. When mixing robotics with solar panels, there is the Smart Flower all-in-one solar power system. It uses robotics and motors to fold out and follow the sun's path. Doing this can generate up to 40% more solar power than a solar panel that sits still. And at the end of the day, it will fold up and clean itself for the night, ready for the next day. People can even build their own DIY solar trackers at home using motors and a 3D printer, as seen by this open source project by the Open Source Classroom. Cubotics was a company that created Solbots. Instead of having expensive individual motors for each solar panel stand, an inexpensive railing was used to connect them all. 2 robots worked together, driving to each solar panel stand to rotate them to face the sun. While one robot made the rounds, the other would be charging. And what about adding drones into the mix? How can they, along with artificial intelligence, add to the solar movement? Drones are used to map out plots of land and calculate the sun's exposure at different times of the day and year. This lets landowners figure out where is the best place to install the solar panels. And drones, along with artificial intelligence, are also able to fly over large solar farms, inspecting solar panels for damaged areas that need repairing. There will be more later in the video on how drones fitted with solar panels can stay flying for months and what they are used for. As drones survey plots of land for the best place to put solar panels, other people and companies are choosing to build on water, creating floating solar farms. One reason for building on water is because there is more space available to build. And another big benefit is that the water keeps the solar panels cooler, making them more efficient. There is the Sekdoorn floating solar farm built on a lake in the Netherlands that was switched on in 2019, and it only took 6 weeks to build. Ocean Sun have been building floating solar farms too. Prototypes have been built on the west coast of Norway, in Singapore, and the Philippines, and they are building full projects in Albania and South Korea. In the western Indian village of Gujarat, a solar power farm has been built on land but spreads across and covers a canal river. Not only does the canal water help keep the solar panels cool, making them up to 5% more efficient, but the shade from the solar panels helps stop the water below from evaporating, saving the water for crops and people. The shade also helps keep the water cleaner as it slows down the growth of algae. The project in India is called the Canals Solar Power Project and covers 750 meters of canal waters in Gujarat. And more states in India have been commissioning builds for solar canal farms. The idea of using solar panels to create protective shade can also be used on land. Agrivoltaics is a way of farming that uses solar panels on farmland while allowing food to grow under them in the shade. Because the crops are growing in the shade, when watering the crops, the water stays on the soil longer and does not evaporate as fast. This saves water as farmers are faced with climate change affecting water supplies and crop growth. Another benefit of growing food crops under shade is that the leaves grow larger as they try to capture as much sunlight as possible. This means you end up with larger leafy food crops ready for eating. The solar panels also provide farmers with a different income source as they sell the energy back to the grid. So far, we have covered using solar panels on land and water, but what about up in the air? Lightweight autonomous drones fitted with solar panels are flying in the skies for months at a time. Some are being worked on so that they can fly up to a year. These are being built to provide internet for undeveloped areas as well as communications, and they can be used for imaging and monitoring areas, for example when natural disasters happen, and for tracking wildfires. Google had a project where they were developing drones to provide internet for rural areas, but they ended up moving onto large balloons instead. Google's balloon project is called Loon, and they use balloons that are as big as a tennis court. These balloons use solar panels to power the equipment that beams down the internet network and keeps the balloons in the right place up in the air. There are also balloon projects being developed to generate solar power. The Sun Hope Project is a project started by Joseph Corey and Dr. Pini Gurfel, an architect and an aerospace engineer. The balloons are filled with helium and are made from a solar integrated fabric. The balloons attach to a power cable, a control panel, and a helium supply cable. This balloon system makes use of vertical space, effectively building in 3D rather than on a 2D plane like normal solar farms. And having balloons that can fly above the clouds allows for uninterrupted solar power. NASA is also looking into using solar balloons, but for the exploration of Mars or even Jupiter and Saturn. When it comes to our homes, the most common place to put solar panels is on the roof. But companies such as Ubiquitous are working on making solar windows possible. They will act just like a normal window, letting you see out, while adding more areas where solar power can be captured. They could also be used as skylights in the roof or as greenhouses in the backyard. Not only will houses be able to use them, but also buildings and cities. But where else could these transparent solar panels be fitted? Car windows would be the other use, or even for mobile phone screens. The idea of making solar panels invisible in windows can also be used for other materials. An Italian company called Diaqua uses recyclable materials to create realistic-looking tiles just like Tesla's roof tiles. But Diaqua are also creating realistic-looking stone, wood, and concrete, which means that they don't just have to go on the roof, they can also be used to cover walls. This allows solar panels to be used with heritage buildings and landscapes, keeping the historical look of a place, since you can avoid using the traditional black rectangle solar panels that are usually put on roofs. These Diaqua invisible solar panels could even be used to make sidewalks or cobbled streets. When it comes to our roads, we can see solar panels being used on cars, as barriers, or even used to make the roads themselves. Elon Musk's Cybertruck can be used in remote locations because of its off-roading capabilities, and adding solar panels to it will allow it to go completely off the grid. Adding solar panels onto the back of the Cybertruck would add 15 miles of range per day, while, as Elon has said, adding fold-out deployable solar wings could add 30 to 40 miles per day. Could this be an Elon Musk side project for developing human transportation vehicles to be used on Mars? When it comes to the streets on Earth, solar panels are being put up as sound barriers in high traffic areas. These types of sound barriers are mostly seen in Europe in countries such as Switzerland, Germany, and Holland. And lastly, there is Solar Roadways, a company who creates specially engineered solar panels that can be walked and driven on. These are smart panels too, as they have microprocessors in them that light up LED lights that act as road markings and can heat up the roads to melt snow and ice, adding to the number of ways that solar panels and solar power will transform our lives in the future, creating a more solar punk world. On the next episode of Venture City, we take a look at Elon Musk and his thoughts on artificial intelligence, and the video will also explain the basics of AI. Hit the thumbs up and subscribe buttons to not miss a video. Solarpunk is a sci-fi.
Hello. We'll
Hello,
back
sir.
again 10:30.
Yes, sir.
Okay, we'll back again 10:30.
Okay,
Thank
sir.
you. See you.
Thank you, sir.
Thank you, sir.
Thank you, my friend.
Yes, Kingsley.
How are you?
Yeah, doing
That was a
great.
good presentation.
Sorry, sir.
So that was an excellent presentation.
Thank you so much. Thank you so much. And how about you? How's in your country condition?
We're doing well.
Oh,
Just
it's very early morning, right?
very early morning for us to start sleeping.
Sorry for that, my friend.
No, it's okay. Thank you.
Welcome to you again. Now we'll discuss about the global scenario of solar photovoltaic energy. And we can see this is the scenario of Europe, global scenario of Europe. They already took many initiative and they took the policy and they took initiative for for sustainable development, and they concern to fully concern about increase okay, increase the green environment and reduce the CO2. So we can see that this is the solar photovoltaic energy. They use also the marine energy. If we look at Finland or Finland, Germany, they concern about the solar, and they produce a huge solar panel, and but also the European countries, based on especially European countries, they focus on renewable energy. They already took many initiative for that, and they already promote it. And at the same time also, like Canada, they took initiative. They focus on they try to develop the renewable energy, like as a solar energy. They promote solar energy, and USA also now promoting the solar energy. They invest huge amount of budget for develop the solar research. MIT and MIT and Harvard, they try to develop, and also in England, Oxford, they try to develop the solar technology. So European country and also the American, they try to develop their solar energy technology. At the same time, they try other renewable energy also. If we look to Europe, like Finland, Germany, France, Italy, and Spain, we can see that they are producing energy from taking energy from solar photovoltaic, and due to the COVID issue. Currently, we know that our environment a little bit stable. So this is the great opportunity to switch renewable energy, because now we have the energy demand. If we compare with before COVID and now, it's a huge difference. And we know from the newspaper or researcher reported that environment now back again like a previous time, going to back. But if we will not take the initiative, and it would be same again, and we will destroy our environment. This is the scenario. 2020 is International Renewable Energy Authority. They reported that the condition of EC is rapidly increased. But if we look after 2011, and it's a huge increase, and then fall down 2040, and again from 2016 to increase, and after 2018 it dramatically increased. So this is the condition of current situation. And scenario of Thailand also, they took many initiative, and we can see that Thailand solar electricity generation is almost 30 more than 3,000 megawatt, and they try to promote it, and the current situation also we can see from here. The Thailand, they produce in 2015, they produce they generate they took electricity from solar 1,298 megawatt, and the target by end of 2036 it would be 6,000 megawatt. And if we compare with other, they also promote other renewable energy, but they only try to focus on solar energy, and it already almost dramatically increased. We can see that Thailand already took initiative, and this is the scenario of, currently. And from 2007 to, we can see how switch the energy scenario of Thailand. And this is it's reported from some researchers. They reported that. And what is the plan policy for Thailand? Thailand, they took initiative like installation of solar rooftop system, 1 million household. So that can back up for household. They can use their own electricity, and that can help also to promote the green. And government has subsidy for that. And also the Thailand hospital, they are using currently, government promote that, and they try to use the solar energy, and e-get supported. And this is the also the in future the school and university also cover the solar energy. So in future prospect, actually, our now many organization, our leaders, they took initiative to reduce the temperature at least 1.5 degree centigrade by end of 2050 to try to drop up and reduce the CO2 emission. And they took many initiative, and many countries, they already, and developing countries such as Thailand, Malaysia, they try to promote the renewable energy. Filipino and some African country also, they try to promote the renewable energy. So if we work together and collaborate each other, and it possible to reduce the CO2 and stop the climate change. So in future, from solar energy, we can see that the maximum we can do 25% more than, and it can help also the total install. Maybe we predict that 8,519 gigawatt. And it can help also our economy. It can help our support our electricity generation. People can get employment. This is the huge industry we can see that from solar photovoltaic energy. And it's free, and in also the cheap cost if we compare with other renewable energy technology. So this is my collaboration. This is my work. I'm working on perovskite solar cell in Malaysia, UKM. And during my previous time, I did before COVID, our some collaboration work. We fabricate the solar energy. He's my professor, Norshad Amin, solar expert in Malaysia. And we try to improve the efficiency, and we got 11% efficiency of a perovskite solar cell. But due to the materials issues, so, and also after COVID, and COVID came, and then we stopped our working. And this is my our research work, collaboration work, and our own work. We published international journal, many articles. I just highlighted 3 of them, and that can we try to contribute, not only think about that, we try to contribute for future sustainable development. And we try to implement the solar energy. This is my our collaboration, international collaboration. We work with that kind of organization, and we have collaboration. We try to promote renewable energy and also develop the technology. So now it's time to the group discussion. I would like to invite all of you to discuss about what is the situation in your country, and what do you think, and how can we promote it, and one by one. I would like to invite Michel first, Mr. Michel.
Is it Michelle or Michael, sir?
Oh, oh, sorry, Michael. Sorry for my mistake.
No problem, no problem. I know it was. All right. Good night. Good night, everybody. a guy from Guyana, South America. I think I introduced myself before, but I'm going to do it to you again, sir. We have started using solar PV energy. We tried not, it's not a large scale, it's on a very small scale.
Sorry, sir. Before I'm interrupting, can you introduce yourself first because I don't know about your background, and then little bit, just 30 seconds, no problem. Please, sir. Hello, Mr. Michael.
Can you hear me, sir?
Yeah, I can hear you. Just introduce little bit about your profession, and then, yeah.
Okay, my name is Michael Belgrave. I'm from Guyana, South America. I work with the Ministry of Natural Resources as a compliance and law enforcement officer. I am here representing the Ministry of Natural Resources, being a part of this program. My job basically is to ensure that compliance in the natural resources sector, that is in terms of our gold, bauxite, diamond, oil, forestry, wildlife, protected areas, and everything. All right, so when it comes to solar energy in my country is not such a big thing. I don't think it's promoted the way it should be promoted and how it should be promoted in terms of its magnitude because of the importance of not just the solar energy, some renewable energy, but we have some form of, we do utilize solar energy in some of our public buildings, but it's just a small percentage of the energy. I think majority of our energy is used by fossil fuel, and like for me, I see solar energy something that we need to, or renewable energy in general, not going to use solar energy.
Sir Michael, Mr. Harmain, can I please unmute your microphone? Then it may not interrupt others. Yeah, please unmute your microphone. Sorry, mute your microphone. Okay, continue, sir.
Yeah, I've seen the increasing need for renewable energy in the country, and like this presentation, this thing is going to be open a floodgate for discussion in terms of getting towards more renewable and clean energy in the future for my country. I'm hoping that whatever discussion I hear can take back to the policymakers and convince them harder on renewable energy, because we are stepping, but we're stepping a bit slow, my country. If you look, you won't see much more.
Michael, excuse me.
I am right there.
There's echo in your audio. Maybe you can turn on other devices that is turned on right now. We can't clearly hear your voice.
Thank you, Mark. Thank you, Mr. Mark. Michael, please continue and turn off your another device if you have, please.
Can you hear me?
Yeah, we can hear you, but some
I
noise.
I'm hearing an echo, but I have my voice on.
Sometimes your voice is not clear.
But can you hear me clear now?
Yeah, we can hear you, but some background noise sometimes is interrupt, and we cannot hear sometimes clearly. Sometimes it's okay.
All right. I'm not sure exactly what is going on because I don't have any other devices on.
Okay. I got your point, Michael. That is that your country based on actually fossil fuel, but still now you may not took big initiative for renewable energy, or maybe you are not focusing on renewable energy. So in your country, do have any like hydropower or others, which renewable energy now you are focusing on that?
Well, we had we started the hydropower plant. They had some work done at that, and for some reason that project was halt. I am not sure what was the reason behind that. So that was a way for us switching into renewable energy, but that project is on hold right now. The project of renewable energy that is actually working, we utilize small amount of solar panel or the solar PV system energy.
Yeah. So yeah, maybe after end of the session, we may get some idea how can promote in your country, because of here we join actually exchange the knowledge. We are from different countries. So we will share first, we will share our experience, our country condition, and then we try to make a solution and try to find out some policy, because maximum person I can see that you are the policy maker for your country, or you are supporter for making a policy in your country. So if you because of you are not I'm not sure, maximum maybe are not from material science. For me, I'm working for develop the technology, but and we can, it's not possible for me. I cannot promote the solar energy. I can develop the technology, but I need your support also, because of the policy maker, they can promote and they make a policy to promote the renewable energy. So due to the actually sound issue, maybe I can call someone, and I can call someone, and later on I'll call you again. Thank you, Michael.
No problem, sir.
Thank you. Mr. Marks?
Yes, sir, I'm here.
Yeah, Mr. Mars, please just little bit introduce yourself within 30 seconds, and then you can continue. You can share with us your country condition. How about renewable energy or solar energy in your country?
Okay, good noon, everyone, for people here in this part of Asia. My name is Mark Kachin. I am from Dipolog City, Zamboanga del Norte, in the Mindanao Island of the Philippines. I currently I'm working in the Department of Science and Technology, mainly focusing on giving assistance to our medium enterprises to understand new technologies to improve their production efficiency, product development, process improvement, manpower development, and so on. Right now, sir, I cannot give you a specific outlook on the renewable energy trend, because I have yet to do some research on this one, as I am scheduled to report on
Mr. Michael, March, you have also same problem. I don't know why. Maybe can you? I couldn't hear clearly before that. Can you explain it again?
Okay, I'm gonna check my other devices.
That's Mike. I suppose all of us are having some echo.
Yeah.
I have no other device on right now. Maybe
okay.
Having multiple devices turned on right now, please.
I think, sir, the problem is at your end, because all of us are experiencing some echo.
Yeah. Pick up. Sound problem, like cannot hear clearly. It's like, March, can you talk again? Sound problem.
Hello, check. Is that good?
Yeah, now okay. Sound.
Sound. You speak?
No. When they speak, it's like noise.
Hello, sir. Is this audio now?
Okay.
Are there no more echoing sounds?
Now a little bit okay. Okay, you can continue.
Okay.
Mark, we cannot hear you. Yeah.
Hello, I was muted.
Okay.
I believe, sir, also if I speak right now, it cannot be very understandable for the audience here. Okay, I will start from the beginning, right?
Okay.
Good morning, everyone. Good noon to all the participants who comes from this part of Asia. My name is Mark Kachin. I work for the Department of Science and Technology, mainly focusing on improving micro, small, and medium enterprises in terms of their process improvement, equipment acquisition, uh, manpower development, and so on to improve their productivity, create new products, uh, and and gain income to provide employment to the community. Sir, I am scheduled to give my country report on July 20, and right now I cannot give you a specific data on the renewable energy consumption or or whatever data that is needed to present right now because I haven't done my research yet. But I assure you that on my scheduled country report on July 20, I will give you a comprehensive report on on renewable energy consumption policies and trends here in this part of the Philippines.
Yeah. Thank you. Actually, not like a country report. It's like what is the scenario in it? It's not. It should not be like a exact amount or exact thing. In your country, available hydro or solar. I want to know something like that. It's not.
Oh,
You
okay.
don't. Yeah.
Okay. Okay, I thought I was going to give the country report. Right now, in this part of the Philippines, we are in the Mindanao area, the southern part of the Philippines. Uh, our current energy is coming from coal. Majority of it comes from coal, but I know that there is a percentage of it comes from hydropower, and more households, including those area where there is uh, not electric connections, people tend to adopt solar energy as their main source of electricity. And there is, I think, in our area here in our province in Zamboanga del Norte, I think there are three firms or three businesses that offers solar panels and solar power installation. So that is the situation here in my part of in this part of the country, and I hope to bring more and more renewable energy power to sustain growth, no, not only in in the rural areas but also in the urban areas where shortage of electricity is very common. No? In a month, maybe there will be blackouts for 1 to 2 days, averaging from 30 minutes to 2 hours. And I think solar energy or other renewable source of energy can greatly uh, positively impact the energy demand, of this area. So I believe that after this course, we will have, or I will have, enough knowledge to be able to uh, create awareness to the people in my place, especially the policymakers, the businessmen, and other stakeholders, that the key to growth economically in the future is to adopt renewable source of energy. It will be costly. It will be, what do you call this? It will be a challenge, but I know with this improvement in the technology, you've mentioned earlier, sir, about the second generation solar panels. I believe that this will be a very welcoming development for places like mine, a developing country, a developing nation, to adopt renewable source of energy. Thank you.
Thank you, Mark, for your wonderful explanation and your thinking. Yeah, you are right, and I believe that you will promote in your country. Here we join actually to share our knowledge. So I believe you also may have also some idea end of the session, and we try to make something how can develop or how can promote or how can we will discuss later about the policy. So now I would like to invite Emma, Mr. or Miss, I'm not sure. Uh, Sorry for that. Emma, Emma, can you hear me? Okay. And Miss Arlene, can you hear me?
Sorry, are you speaking?
Okay,
Are you
okay, okay.
trying to look for AMA or yeah, AMA?
Yeah, Amma. Thank you,
Yeah.
sir.
So sorry for
Yeah.
sorry for that. I'm still yeah. Good morning. Do I need to turn on my yeah? Sorry, so that they could see me.
Could you explain something? Yeah, thank you, sir.
Yeah, thank you. Sorry. Currently, I'm also from Philippines. I just want to add to some. Do you still want to give me some info about the Philippines status on the solar energy? Because, yeah. Currently, I have here the data for the sorry, I cannot share. I was still looking for the soft copies. I have some difficulty. Anyway, we have here the data for the power generation by source in gigawatt hour totally in the Philippines. Currently, we have a total of 101,756.
Sorry for interrupt. Before go to Emma, could you tell me your profession? Because this is
sorry.
first time. Sorry
Yeah.
for that.
Okay, thank you. I am Amante Ama. I'm already a graduate of Doctor of Philosophy in Physics. I'm a physicist, but I am especially specializing on photonics. But I am also doing some experimentations in doing renewable energy resources. Also the photovoltaic cell. I am currently developing some organic solar cells. Crudely, because we don't have those kind of lab in your place. We are trying to use different dyes, local dyes in the Philippines, and we are trying also to use some polymer to maximize the efficiency of the dye sensitized solar cell and other possible. Is that very clear?
Yeah. Clear.
Okay, so as I have mentioned earlier, the total power generation by source in the Philippines is 101,756 gigawatt hour, so energy. So currently, this is the data for 2020, although I have a lot of data here from 2003. So this is the last year data. So how about the solar energy? We have currently 1,373 gigawatt hour. So it is about 1.35% generation. I mean, in relation to the total generation. So currently we are already investing in solar cells or solar energy, and in our region, we are already building some solar power plants using solar cells or solar panels, and we are also exploring energy by solar cell by installing that in our buildings using this called green technology. So we are already starting to build buildings with solar cells. So that is currently the status in our place. But we still have a long way to go to at least have more solar power plants. That's all. Thank
And
you.
do you have any plan for working on perovskite solar cell?
Yes, of course.
Yeah, because you are working organic, and could you share some experience about that?
Organic solar cell?
Yeah.
In our previous experiments, we are just using the usual crude creation of the PN junctions. We use the titanium dioxide as our substrate for the dye, you know that. And of course, we just use the usual carbon coating through candlestick thing in our first experimentations. But now we are trying to embed the carbon in our ITO, indium tin oxide, because our conductive glass slide is ITO coated glass slides. We imported that from Singapore and of course from China in our earlier. Our new thing here, the improvement now in our experimentations, rather than coating we use spin coating on we try to use the process spin coating for the titanium dioxide in the glass slides, and rather than using the usual carbon deposition to the glass slides or the conductive glass slides, we are now using laser lithography so that we can produce carbon. And we have also a local polymer here that is because the polymer now is also a very promising material for high storage of energy, say for instance in the batteries. So we are also exploring that if we can have a much more faster electron transfer so that we could have also a high efficiency for our organic solar cells. I suppose that's all. And currently we are not yet done for we don't have yet data for our new explorations.
Yeah. Because of that's why we are in now one platform TICA arranged for that. You see, due to the limitation of lab facility, you cannot explore your knowledge, but you have the idea. So how could you explore your idea? So how could you develop your idea? So if you have the good connection with a good laboratory, so you may have some working facility, because now for sustainable development, we collaborate each other. For me, like I try to develop my during my master's, I try to develop my perovskite solar cell efficiency development. So I have some lackings of lab facilities in Thailand. So I collaborate with the University of Malaya and University University Kabangsaan, Malaysia. So my professor, he's the top 3 listed in Malaysia, Professor Norshad Amin, based on solar cell. So I work with them, and I did some according to that I could publish some publication, international publication. So that's why. So I believe that you will find also some collaboration in this platform, and you can explore your knowledge and you can develop your idea also. Yeah.
Thank you for that. Thank you.
Yeah. I will come again because of this is the some of us, we are thinking about technology, but we need to implement, because one person cannot establish the method. We need to corporate social responsibility. We need a policy maker. We need investor and technology development all in one platform. Then we can establish or we can promote one thing. So here is that we are many people and we are from different background. So we may develop, we have the opportunity to develop the policy, right? So yeah, we'll discuss it later. So now I would like to invite Kia. Kia, if I don't make mistake, sorry for that if I make mistake. Can you hear me? Kia? Okay, okay, I can invite another person. I will call you later. So our solar man, Mr. Harmewan, Mr. Harmewan. Can you, sir, unmute yourself? Mr. Harmewan, can you hear me?
Do you mean Febriansyah?
Hello?
Do you mean Febriansyah?
Sorry? Yeah.
Hermawan Febriansyah. Hi.
Okay. Piansha, right? Hello?
Yeah, hello. Yes.
Yeah. Please, sir, please some discuss with us some of your knowledge, or how about in your country about the solar photovoltaic. Share with us. First, introduce little bit about your profession and then start.
Okay, thank you. Thank you for your invitation to sharing from my country. I'm Herman Febriansyah. I'm researcher from National Standardization Agency of Indonesia. Now, because in the pandemic, now I'm in home. I'm work from home. So sorry, my uniform is not properly.
So this is now common because we have to ready anytime. So this is our now professional dress, no problem.
Okay. Sorry. I would like to share my country up for maybe I would like to share from my energy country report as data I obtained from.
Sir, it's not country report. I want to know about current situation of solar photovoltaic. And do you have any like idea, or you can share something about you? Because country report is later. So you just share about the solar photovoltaic and what do you think?
Okay. Okay. Because I work in National Station Agency, now we concern in standard for solar PV. As you know, maybe floor standard for PV module has been standardized in Indonesia. So its PV modules used in Indonesia must be comply with standards. Now, the development of solar PV in Indonesia concerning to building the industry, because we have a projection for Indonesia in solar PV will continue to increase maybe to target of Indonesia renewable energy in 2025 for 23% from renewable energy in Indonesia energy mix. So we have concern to standardize and industrialize solar PV, and we have a program as you present before about rooftop. We will campaign to public about PV rooftop installation, and we have regulation to give like we call it prosumer. So the public can sell the electricity from the PV rooftop. I think now the development progress for solar PV in Indonesia is about to campaign. It's about to campaign how can people aware to use solar PV in home, because now Indonesia is trying to release the impedance from sorry, we avoid from fossil energy. So as you know, Indonesia now use about more or half for fossil energy. So we try to decrease fossil energy to transition to renewable energy. So we concern in solar PV, especially in rooftop. Yeah, thank you.
Thank you, sir. Thank you so much for your wonderful presentation. It's like, you know, I can see the future leader of Indonesia. It's not like you are the leader for, you will lead the energy sector and you will promote your energy, because we know that Indonesia, every year they feel natural disaster, right? Tsunami or something like that. So yeah, so you see, we we try to developing our technology at the same time. Some of country, because those are near the sea, they are sufferer. So at the same, also Japan also, like of you, they are also suffer many things. But this is the way to develop our solar photovoltaic energy, because it's cost, it's not cost not too much high, and we can replace it easily, and also the lifetime also almost 20 to 25 years. So that is the big achievement. And you know, theoretically now efficiency almost more than 40 or 50, but we try to develop, because of due to the material issue, researchers, they are trying to develop the materials, develop the material and synthesis, because that's why still now we are in 20, maybe in future, you see, we are now, we try to do the relax, just don't want to do hard work, like our device also would be like in future, lack of electricity, but they will give us more product efficiency. For example, just last year maybe, Apple, they announced their first announced M1 chip. So if we compare with other Intel laptop or computer, it's like Intel Apple laptop, Apple Mac Pro, the Intel one 16 GB RAM, and that one only 8 GB RAM, but work ability is same, you see. So we are going to actually that generation, and maybe in future we can't think anything about without solar. We'll utilize it. Thank you so much, sir. And now I would like to invite Miss Arlene.
Hello, sir.
Hello,
Good
sir. Yeah, Miss Arlene.
afternoon here from the Philippines.
Wow, many Filipinos.
There are a lot of
Filipino leaders.
Filipino participants in this seminar. Just a short introduction about me. I am a teacher for college students here in the Philippines. I teach in Bicol State College of Applied Sciences and Technology, and I am handling science subjects. Well, I train future educators, and I believe that my role as a teacher, training teachers, is also important on how we educate them about the concepts on global warming and environmental issues. Um, for the situation of in our country about power supply, I think it was already discussed a while ago by my colleagues, but um, majority of our power supply are really coming from coal. 40% of our consumption are coming from coal or fossil fuels. But I am happy to say that there are a bigger number of Filipinos now who are becoming more aware of investing on renewable energy resources. Just to share, in our barangay, it's a small community. There is already a project. They are about to build a solar farm in our nearby barangay, and I think that is a one important kumbaga, project that to build up another source of renewable energy in our area. Now, the only problem is that I think the resources will still be not to be consumed by the immediate community, because we have a problem with the energy distribution. In our area, there was this monopoly of power when it comes to energy distribution. The distribution were provided by selected companies, private companies, and because of that, the price of power supply in our area is very high, and we are also experiencing series of blackouts in our area. So that's the situation in our area, sir.
Thank you, Teacher Arlene. Teacher Arlene, what is your contribution? You are working from base, like how to develop the base, because you work on awareness. If we are producing lots of renewable energy, okay, 100% from renewable energy, but people don't aware about that. They just wasted of electricity, that also. So you are working to you may help them to think, people think them, and your society to teach them uh, how they save their energy, they don't waste energy. This is not the solution, this is not a solution. Like we produce electricity from solar photovoltaic, at the same time we have to think also in future. We every when we are gonna do anything, we have to think first. Awareness is the best policy, because we need to aware wastage of electricity. For example, someone may be in the office, out of office, but aircon or light on, so this wasted, right? So huge
Yes.
wastage also. So we need to awareness also, you see. So that is your main contribution. You can help your students to develop their psychology and develop their positive mentality. How can they become a great person? Thank you so much, Arlene.
Yes, sir. Thank you, sir.
Thank you so much. And now I would like to invite Birendra, Mr. Birendra. Mr. Birendra.
Hello.
Hello, sir. Mr. Birendra.
Okay, sorry, I came here to only listen. I did not prepare any materials.
Oh, okay, sir. No need to prepare any material. That just share your experience about the solar energy in your country, or what do you think, and how can you contribute, or what? Just it's not. It's just discussion. We will.
And then, okay, later then I will talk.
Okay, sir. Okay, sir. Okay, may I invite Kaya? Kaya. Kaya Finido. Okay, sir, we may go for another break, and you may prepare your country's situation, and then we can discuss about that issue. Are you okay, all of you?
Hello.
Yes, yes, I can hear you. Please share your.
Okay, sir. I am Julie, coming from the Philippines. So I am a researcher also and a professor in a state university teaching sciences subject. No.
Yes, sir.
So I would like to share my updates actually in our country about the solar panel. So the solar panel market in the Philippines has been growing exponentially, no, since 2018. In fact, the Philippines Board of Investments had provided 8 solar projects that year. So the Solar Philippines Commercial Rooftop Projects Incorporated oversaw all 8 that were equally equivalent to $1.65 billion of investment. So even though, as of today, the solar power industry is still on the emerging stage in the country, it is expected to gain massive support from the government moving forward. So some of the factors that will drive growth in the solar energy sector are the growing population in the country, as well as the Philippines' rapid economic growth. So when the Philippines succeeds in replacing diesel generators in most islands, because Philippines is an archipelago, with solar energy, there will be a significant reduction in power outages in the country. So solar energy and other renewable energy sources will guarantee grid stability throughout the Philippines. So I am pointing here 4 main trends in solar energy in the Philippines. So number 1, the accessibility for private households in the country. So in a couple of years, utility scale of solar was difficult to achieve due to the market's regulatory changes in the country. So the price computation was too high, and only the largest capitalized developers could compete. No? So that's the first trend. So the second one, the significant growth of solar PV or the photovoltaic cell. When we see photovoltaic cell, this is the semiconductor device that converts the light into electrical energy. So the production cost of solar energy is expected to fall significantly between 2020 and 2025. I am talking here the 5 years, 5 years gap, or 5 years. So as a result, the projected result, the solar will take first place for the cheapest source of energy in the Philippines. So the growth of photovoltaic systems in the Philippines will I'm sure provide an immediate and more permanent solution to the country's energy needs, because as of now we have many cutouts in electricity because of the short supply coming from the power plant. So the market is already registering a significant fall in the cost of photovoltaic cells. And many households are jumping on this bandwagon and taking advantage of the affordability of solar equipment here in the country. And the third trend is the increased grid parity. So when we see grid parity, this is the point when the cost of the alternative energy becomes equal to or from conventional energy forms like the fossil fuels, because in the Philippines we have huge population increase, and without alternative source of energy, the grid easily gets unstable. However, due to the introduction of renewable sources of energy like the solar and wind, because we have this already in the country, we have wind energy in Luzon and somewhere in Visayas, no? So we can see a future where grid parity is guaranteed. And the last one trend is the storage, no? So there are plans underway to develop solar storage microgrids in the Philippines. So when this plan succeeds, so solar energy will play a huge role in improving environmental health, human health, as well as people's quality of life. So this will be a huge step towards achieving Philippines' national climate change. Because now we are also affected with the climate change, greenhouse gas emissions reduction, and renewable energy goals. So solar energy production allows the Philippines to reduce its regions on fuel. The transition to low carbon energy sources like wind and solar opens up economic development opportunities from a climate perspective. So in general, harnessing solar energy has ensured that many households in the Philippines can make it through hot and humid days. So solar air conditioners allow homeowners to achieve a comfortable indoor environment without digging too deep into their pockets. So these latest trends show that things are only getting better. So we can see a future where solar energy is the main source of electricity in the Philippines. Okay, that's all, sir, that I can share with you here in our country. Thank you very much.
Thank you, Sir Julie. Yeah, this is the true, and this is the real scenario. Not only Filipino, over the world actually. So we may some of company they can because of actually install of a solar photovoltaic is expensive. But if we think 20 years, serving 20 years, so after 1 or 2 years it like as free electricity. So for that, maybe government can make some policy, or company they can start like installment, so that can help also to promote our solar energy in future, not only Filipino, over the world or developing countries. Thank you so much, Julia. Now I would like to invite Marcelo, Mr. Marcelo.
Hello, everyone. So can you hear me? Can you confirm that my audio is okay?
Yeah, okay. You're audible. The sound is very good.
Okay, thank you very much. So hello, I would like to introduce myself. My name is Marcelo Calispa. I'm from Ecuador, from South America.
Yes, sir.
And I think here in my country related with this solar energy. But first of all, I would like also to introduce myself as my background. So I am a mechanical engineer, and I got a master's degree, a Master of Philosophy in Mechanical and System Engineering from the University of Newcastle in England.
Wow.
And I studied, when I did my master's degree, I studied something more related with biogas production, and it's also related with renewable energies. But anyway, I also have a master's degree in mathematics and simulation, so I'm more focusing in that area. But I know some of the renewable energies here in my country, and since I'm working as an undergrad lecturer, I'm trying to teaching this kind of renewable energies to undergraduate students as well. So from my point of view, as far as I know, the electricity capacity and generation from my country, from Ecuador, it's most based on hydropower. From all the electricity that we produce and we use, the 96% of the electricity is produced by hydropower. And only the 4% of the 4% of the renewable energy producing electricity, it's including bioenergy, geothermal, wind, and solar. So I think in terms of the percentage, I think solar here in Ecuador is less than 0.1%. So it's really, really small compared to the other renewable energies. But I think the potential energy related with solar energy here in Ecuador is really, really big, because we are in the kind of in the middle of the planet, and we have a lot of radiation here. So the potential of solar energy here it's huge. But probably in order to support more this kind of renewable energy, the solar energy, we need to implement some economic incentives from the government. But nowadays, the government is more focused on creating or building new hydropower plants. So it's because we have this resource more available, and the government think that it's more stable as well. So the government is investing more money in this energy, not even in my field, not even in the bioenergy, and they are more focusing in these other renewables. And also, we are an oil producer country, so we produce a lot of oil, and also we have energy generation from that side as well. So, but I think in the future, the population will increase also, and the demand of energy as also will increase. So basically, we will need more sources of energy from all the sources, and in some point we will also increase the use of solar energy here. So I think in the future it will change a little bit, but in general, I would say that the country will still keep building more hydropower plants, and also in investing more in wind energy, which is kind of the projects the government is developing right now. So that is, I could say, something related to solar energy from my country. Thanks.
Thank you, Marcelo. Thank you for wonderful presentation. Your country is like an idol for how to promote the renewable energy. I believe in future when solar car will be available, that time, yeah, maybe people try to use it and utilize it. And yeah, your country is the idol for others country, like how can depend only renewable energy. Yeah, thank you so much for your explanation. Now I would like
Thank you very much.
Thank you, sir. Now I would like to invite Srithol. Miss Srithol, can you hear me? Sure. Srithol. And anyone would like to share experience, Kaya or other anyone, Birendra? Maria? Anyone? Okay, thank you, sir. Thank you so much. That's it. Actually, today solar photovoltaic. We already discussed about that. Our country already trying to promote the solar photovoltaic energy, and we will try also the solar photovoltaic energy, because I believe that you are all a leader from your country, and you are in the leading position in your country. So, and we also make the collaboration. This is a opportunity for us, TICA create for us all in one platform, and we make a collaboration and we exchange our knowledge, and we can implement in our country. And that is the big thing, and this is the way of for sustainable development. making collaboration, connect with many people and share the knowledge and technology and everything. Thank you so much, sir, for your attention. Tomorrow I have a session for solar thermal and green roof, but unfortunately today I will take a vaccine, so I will switch it 20. And day after tomorrow, see you again. And stay safe and keep the distance with your friend, or when you went to outside, go to outside, and take care of yourself. Thank you so much, sir.
Okay, thank you, sir.
Thank you,
Thank
sir.
you,
Stay
sir.
safe, everyone.
And also, sir, if anyone would like to collaborate or anything, because I already share my email address, so please, anytime we can work together for in future also. Thank you, sir.